All right, guys, welcome back. This is going to be the second part to the 8.4 instructional video. In this video, we're just going to cover examples. So if you haven't watched the 8.4 part 1 yet, please go back and do that, or this video won't make a ton of sense. In the first example, we're going to start with an 8.4 part 2 here. Got the wrong sheet. We are going to start with a to the 4 squared times a to the second to the fifth. And I'd encourage you to try this one on your own. You should be able, after watching the 8.4.1 or 8.4 part 1, should be able to solve this, hopefully with relative ease. So hopefully you took a shot on your own in your notes and have solved it at this point. What 8.4 was all about was how do we handle power to a power, and through some logicking that we saw in 8.4 part 1, we know that if I have a base to an exponent going to another exponent, like a to the 4 squared, I simply just need to multiply the exponents together. And really, though, what I want to observe is all that's going on here. A to the 4 to the second is an exponent, times a to the second to the fifth, which is an exponent. So I have two exponent situations and a multiplication. According to order operations, I want to handle the exponents first. So I use my power to a power rule, and I get a to the 8th. And that will be multiplied by a to the 10th, again, applying my power to a power rule. Notice I handle the exponents before I ever do multiplication. Again, this is due to the order of operations. So how can I simplify a to the 8th times a to the 10th? Well, we've already learned this. If you aren't sure why this happens, check out the 8.3 video. But we have like bases multiplied together, and so we can add the exponents. And I end up with a to the 18th power. A to the 18th power. So let's look at another example. 2x squared to the 4th. Again, I would encourage you to try this one on your own. Now, on the surface, this example looks fairly similar to the one we just did. In fact, it might look a little bit easier because we only have one set of parentheses. But I think it's actually a little more complicated. And I think, and what I would encourage you to do is if you did this on your own and you got 2x to the 8th, you are close, but you are wrong. 2x to the 8th is not the answer. Let me explain why and explain how this situation is a little different. As we have always said, to understand exponents, when in doubt, write them out. So let's write out what 2x squared to the 4th means. What that means is I have 4 2x squareds multiplied together. Exponents are repeated multiplication. And using my 4.3 logic, what I can do, or not 4.3, 8.3 logic, I notice that I have a bunch of stuff multiplied together, right? How are all these 2's attached to the x squareds? Well, they're being multiplied. Put in some little multiplication symbols there. And we know by the commutative property, which we've discussed in other videos, that when I have a bunch of stuff multiplied together, I can reorder it however I would like. And what we end up with is 2 times 2 is 4, times 2 is 8, times 2 is 16. And I have 4 like bases multiplied together, so I add all their exponents, and I end up with x to the 8th. So instead of 2x to the 8th, I should end up with 16x to the 8th, and we can see that from writing it out. Now let's go back to the original problem and see if there was maybe an easier way to solve it. And why this one is different than other ones is in the past we've seen problems such as x squared to the 4th, and we said power to a power, multiply the exponents, we're out of there, no problem. But this is not just a power to a power situation. Rather, it is a product to a power. Why is it a product to a power? Because I have two things multiplied together going to an exponent. I have 2 times x squared, that is all to the fourth power. So I have to handle that a little bit differently. Now I'm still going to apply the power to a power logic. It's how we end up with x to the 8th. But what I need to do is I need to essentially distribute the exponent to both aspects of the product. Not only do I need to multiply the 4 by the 2, but I also need to distribute the 4 to the exponent of the base 2, right? The x squared just doesn't get the 4. The 2 does as well, okay? Product to a power versus power to a power, okay? Well, how are we going to distribute this? The next common mistake people make is they go, okay, Mr. Carter, 4 times 2 is 8, so why isn't it 8x to the 8th? Well, again, when we do power to a power, we multiply the exponents, not the base times an exponent. So what I'm going to do is I don't see an exponent with the 2, but we know anything without an exponent can be written as an exponent to the first power. So when I distribute the 4, I'm going to write that 1 in, and then what we'll be doing is we will get 2 to the 4th power, right? Power to a power, we multiply the exponents. So I get 2 to the 4th times x to the 2 times 4 is 8. So I end up with 2 to the 4th times x to the 8th, which is 16x to the 8, which is what we got when we wrote it out. What this leads us into is our next little rule for 8.4 here. If you have a product raised to a power, not a power to a power, but a product raised to a power, in general, what we can say is, let's say I have some number a and some number b to the n, then what this will equal is a to the n times b to the n. Okay, we have a product, we have multiple things being multiplied together to an exponent. Each parts of the product will get the exponent, okay? And again, they will get the exponent by the power to a power logic. Right here I do 1 times n, and I get b to the n. 1 times a, I get a to the n, and that a to the n, b to the n are still multiplied together. Okay? Now let's go through another example together. Maybe this will help clarify things if you're a little bit confused right now. 4g to the 5th to the -2nd. And again, I recognize immediately this is a product to a power. Why? Because we don't just have g to the 5th to the -2nd. Rather, I have 4, which is attached to the g to the 5th by multiplication. And that whole quantity is to the -2nd power. So we have a product to a power. What's our little shortcut? Well, we distribute the exponent to each part of the product. But before I do that, to avoid messing this up, I'm going to make sure I give the 4 an exponent. Since we don't see one written there, we will write the exponent as 1. Again, what people are often tempted to do that I don't want you to do is distribute the -2 to the 5 fine, but then they accidentally do 4 times -2 because they don't see an exponent with the 4, and that's not what we want. Power to a power multiplies the exponents. You don't see an exponent with the part of the product, write the exponent as a 1. So again, for product to a power, we distribute the exponent to each part of the product. Power to a power says multiply. So I'm going to have 4 to the 2nd, because 2 times 1 is, or 4 to the -2nd, because -2 times 1 is -2, times g to the -10th, again 5 to the -2nd, multiply those and I get -10. And hopefully you see this is very similar to the power to a power problems that we did in the previous video. We just have an added step of making sure that when we have a product, every part of the product gets that exponent distributed to it. Well, at this point, again, we're not quite done. Why? Because we have some simplification we can do. We can get rid, or not get rid, but rewrite our negative exponents as positive exponents by moving them to the denominator. Again, that's covered in 8.1. And the last bit of simplification I can do is I can rewrite 4 squared as 16. And I end up with 1 over 16 g to the 10th. Let's do 2 more examples together. And these are pretty complex. So I would encourage you to try them on your own. If you don't get them quite right, follow me once I do them, and make sure you really got this down before you move on to the practice. And what makes these next 2 examples so tricky is surely the fact that there's so much going on. There's so much to handle. To curb maybe those worries that go, I have no idea where to start, remember your order of operations. According to order of operations, parentheses, exponents, multiplication, division are together, and then addition and subtraction. So I see 2 sets of parentheses here being multiplied together. And what I see outside those parentheses are exponents. And those parentheses are attached via multiplication. There's some multiplication going on in the one set of parentheses. So I see a lot of multiplication and exponents, but before I handle any of the multiplication, order of operations tells me to handle the exponents. So I look at this first set of parentheses and I see a power to a power situation going on. So I multiply the exponents and I get x to the negative 4th. This will be multiplied by the other set of the parentheses, but I'm not going to distribute that x to the negative 4th in, right? I'm not going to start any multiplying before I handle my exponents. Here in this other exponent, I don't have a power to a power. I have a product to a power going on. So what I'm going to do is I'm going to make all of these exponents 1. This will just help me in my distribution of the exponent. Now what I will do is I'll distribute this exponent, making sure each part of the product, or everything that's being multiplied together, gets the exponent. And I get 3 to the 4th power, because 4 times 1 is 3, or 4 times 1 is 4. X to the 4th power, because 1 times 4 is 4. And y to the 8th power, because 2 times 4 is 4. And again, these are all, as we know, multiplied together. So I handle my exponents first. I add a power to a power and a product to a power. Now what I'm going to do is I'm going to use my 8.3 knowledge to simplify this. Since they're all multiplied together by the commutative property, I can reorganize these. And we can now do some simplification. 3 to the 4th power is 81. I have like bases multiplied together with the x to the negative 4th and x to the 4th. So I can rewrite, or I can add to simplify, when you have like bases multiplied together, we can add the exponents. Well, when I do that, maybe I'll write that off to the side here. X to the negative 4th times x to the 4th. I add the exponents and I get x to the 0. And we know x to the 0 is just 1. And then we have our y to the 8th. Well, anything times 1 is just itself. So the simplified answer for this problem would be 81y to the 8th. Let's do one more example. We have 6 mn cubed, and then 5m to the negative 3rd, and that whole quantity squared. So again, try this on your own. Pause the video. Again, similar to the last problem, a lot going on. Order of operations tells me, hey, handle your parentheses first. Handle your parentheses first. So I'm going to simplify what's in each parenthesis. Then I will look to combine. Since we have 2 parentheses next to each other, we'll look to combine with multiplication. So when I look at the first set of parentheses, again, I see 6 m and n multiplied together. But before I do anything there, we need to handle the exponent. Again, before I ever distribute an exponent, because this is a product to a power scenario, I want to write the exponent of 1. This just prevents me from making any errors when I do power to a power for each parts of these products. And I get 6 to the third, m to the third, n to the third. And again, that was our first set of parentheses. And that will all be multiplied with the second set. In addition, all of these are attached via multiplication. Again, products were put to a power. Same idea over here, product to a power. The 5 is being multiplied by the m to the negative third. That whole thing was put to the second. Before I distribute, again, I'm going to write 5 to the first power so I don't make any errors. And we get 5 to the second, m to the negative sixth. So what I'm going to do now, since they're all multiplied together, reorder. And now we'll do some simplification. 6 to the third is 216. 5 squared is 25. Like bases multiplied together. Add the exponents. This will multiply together to be 5,400. And then we move our negative exponent to the denominator. So hopefully now that you've seen several examples and we've introduced the idea for product to a power, hopefully you feel good about the concepts. If you don't, feel free to shoot me an email. Again, all we're looking at here with product to a power is the same as the power to a power idea we used in the first part of 8.4, except we have to make sure with product to a power, each part of the product gets the exponent distributed to it. Guys, thanks for watching. Have a good day.